solar heating and cooling from rainwater. All made possible by a solar heat pump module applied to any home with a solar photovoltaic array of at least 1 kilowatt. Perfect for use on our cyber garage. The advantage of this system is that it works great when the size of the solar array is limited. It makes small systems practical and effective. And it works well with this 2-story passive solar house. This house has 2 sump pumps, which are needed on this wooded urban lot, which produces a lot of runoff. One in the front and one in the back. The sump pumps look like this. They remove water to keep the basement dry and discharge it into the front and backyard as required by law in this city. And typical systems throughout this community, some perhaps way more than they know, must redischarge some of the water that was pumped out, because it drains back slowly over time. Eventually it all drains away somewhere, but some pumps in typical homes in northern Wisconsin run all year round, even in the driest summers and coldest winters. It provides the unique opportunity to harvest geothermal heat surrounded by the home in Wisconsin with a sump pump, very inexpensively and efficiently. Here's how it works. Starting in spring, melting snow and rainwater is absorbed in the ground and ends up regularly extracted by the sump pump. In its path, it picks up the heat of the earth, picking up 10, 20, or 30 degrees of geothermal heat. Every day, rain or shine, the solar PV pumps the heat pump, extracting that heat into a tank that supplies heat to the house. At any time there is a need, the heat is delivered to the house, in this case, with a radiant slab floor. Depending on the day, date, time, and need, the solar panel provides all the power to do the job, enhanced by the geothermal and the high coefficient of performance of the heat pump. This is a huge advantage. You can see it in action here. Rerouted above ground so to be seen, the discharge has been split to evenly distribute water far away from the home. Each wet spot that you see essentially represents a source point from which the water will extract heat on its way back to the sump pump. And it's a large area. And if it rains, it's going to be even larger. That wetness that you can see on the slate path pretty well illustrates the evidence of discharge recirculation, which you're going to have. And it's a good thing. Okay, and now let's talk about cooling in the summer. This is where the system really shines. Let's take, for example, a rainy day in July that provides lots of water that seeps through the soil and heads towards the sump pump. Before it gets there, it is cooled by the earth 10, 20, maybe 30 degrees by the temperature of the soil it passes through. Perhaps at the same time, even in the rain, there's enough electricity generated by the solar panels to run the heat pump, socking away gallons and gallons of cold water to be used to cool the house all day long. And given a good rainstorm once in a while, more frequent now here in Wisconsin, and perhaps some adjustments to the recirculation effectiveness of your sump pump, you'll have more than enough geothermal cooling capacity for the whole summer. And again, just like in the winter, depending on the daytime date and the need, the solar panel provides all the power to do the job, enhanced by the geothermal and the high coefficient of performance of the heat pump. Again, a huge advantage. And of course, going forward to fall, all the heat of the summer is now kind of stored in the soil around the house to be extracted by early winter rain and delivered likely as efficiently as it was in the spring. This heating and cooling of the ground year after year may add to the effectiveness of the system as a whole as annual storage benefits. The dead of winter. Worst case scenario, solar panels do not work when covered with snow. But good news is that global warming brings far more January thaw events than ever before in Wisconsin. And with these events, the rain washes off the snow, melts snow on the ground, and replenishes the flow of the sump pump water that feeds the heat pump. And every day, rain or shine, that the panels are free and clear of snow will be a big boost of heat for the hot water tank holding the heat for the house. A grid tie home with gas or even wood source backup will save the day and only add some heat requirements from fossil sources. That's a lot to digest. And future videos on how the heat pump module works and how it can be used with other geothermal sources will help clarify things if this is confusing. So please subscribe and click the bell for more. This is going to be one of the subjects. We call them geothermal heat pipes. Whoa. Okay, let's get to the bottom line here. By combining a direct current operation of a solar heat pump module combined with geothermal extraction of rain and runoff water, you get a system that's far superior to any grid tie or battery combination solar systems and any geothermal system available today. It is a quantum leap forward, offering more economical and better alternative power utilization of solar energy. Okay, I think that's all for now. Be sure to check out our website for more information and perhaps even order plans for a cyber garage for your Cybertruck. And thanks for watching.